Good morning, students. Today, I will continue. First of all, I will continue for you to presenting part of lecture which is related to statistical and general data analysis by using spreadsheet, for example, Excel. And by the end of lecture, we will move into next topic, which is related to information system. So remaining part of lecture on biostatistics method, including correlational, regressional analysis, and basic introduction to optimal management task solving with spreadsheet. Let's proceed with correlational analysis quickly. So it's kind of statistical technique that it can be shown whether how strongly pairs of variables are related. In definition, immediately given emphasis that only two variables has been analyzed at a time with this method. Results is measured as coefficient of correlation, which range from -0 to +0, which indicate strong positive negative correlation, and values related to 0 indicate absence of correlation. In addition to correlation coefficient, its square version or coefficient of determination also has been used to show percentage of variation in dependent variable, which explained by independent or predictor. So, combination of both, here is important to understand that coefficient of correlation could be used separately, where there is coefficient of determination not exactly explain the correlation in variables. So when we again back to little bit another version of flowchart of different statistics method which use it for performing statistical analysis. So here, as you can see, place of correlation, and again we have at least two different versions of correlation depending of distribution type what we have in our data. And as you can see, it's still in a row with other methods, including hypothesis testing. Previous time I showed for you another version of this chart which allow only make choice for hypothesis testing. But as you can see, all this question can be combined together, and depending of what we have, like uni or multivariable data sets, and what we are looking about difference correlation or so, so we can make choice. We have more choice of various statistical method for data analysis. As I already said, we have two types of correlation coefficient, and correct usage depend of distribution time that's variable being suited. Pearson product mode correlation required that variables must be normally distributed, and Spearman-Rand correlation coefficient appropriate when variables skewed or ordinal, and robust when extreme value present. And here is we have actually formulas for both, how we can make calculation manually. And at right side presented for you some one of possible approach how we made assessment about how strong of correlation is. So with given limits, we can spoken about from negligible correlation when our results are closely to zero and to very high positive, to very high correlation, positive, negative, depending to sign when we have value between 0.9 and 1. And actually, if we try to use a spreadsheet for correlational analysis, so here is example of ideal positive negative correlation and usage of Corel function which expect two arguments, range for x and y variables. And again, every time it's important to understand that built-in Corel function implement Pearson correlation, so it's provide valid result only in case if your data is normally distributed. And as you can see, it's also very easy to assume what is means positive negative correlation. In case of positive correlation, both data variables follow up one another. And in case of ideal negative correlation, we have to spoken about something like mirroring of variables values. That's another alternative to calculate correlation with spreadsheet is to use correlation tool and the analysis toolpack. The only difference and benefits of this tool, it's allowed to obtain matrix of all possible paired correlations. So it's useful in case when you have more than two variables and you want to obtain all possible correlation. I think this time I will show practice at each point. So here is, let's move into my worksheet, and I have some variables to visualize, to analyze. So as I said from previous lecture, it's fine idea to visualize it with chart. And if you want just display our data, in this case, because sample is ordinal variable, like independent variable is definitely sample number, and it's ordinal variable, so definitely it's absolutely correct to insert line chart to visualize our data only, so we can make some visual assessment on this. If we want directly now or visualize possible correlation between data set, so it's like a fine idea to have to use scatter plot, but this time it will be correct. So here is we have correlation between x and y, for example. Okay, let me insert it, correlation between x and y. Or, for example, if I want to even try to get all correlations, so here is will be correlation between x and y and x and z respectively. Keep in mind that x-axis here is given in horizontal direction and it's not presented on dataset in this case. Here is we have direct correlation between variables, not visualization. And for sure it's pretty easy to make correlation with Corel function. So I have just provide like two arguments, for example, first pair of variables, and I will get my result. And if I want to decide to use correlational tool, then I can get all my three variables fit together. Have labels, samples in columns, my output range has to be here. Okay, so as you can see, here is matched value when it's correlation coefficient between x and y. Here is we have high positive correlation, high negative correlation between x and z, and moderate between z and y. So here is we have like two possible, let me check in this way, like this. And actually our chart, it's easy to determine where do we have positive, negative correlation. It's pretty visible. Okay, let's move into next analysis and switch to regression analysis. So regression analysis, it's a set of statistical methods used the estimation of I'm sorry. Of relationship between dependent variable and one or more independent variable. It can be utilized to assess range of relationship between variables for modeling the future relationship between them. And one of this method is curve fitting. This process trying to find the curve which represent by some model equation and best represents that sample data, or more specifically relationship between independent data set. So let's remind most common models like linear trend line, which expect we need to know at least two coefficient can be was determined during curve fitting process. Logarithmic trend line dedicated to identification of C and B parameters of logarithmic model. With power trend line, again, we have two coefficient and power value have to be identified. Exponential trend line, same way. And with polynomial trend line, aim is to identify each one C coefficient and remember B as parameters of curve fit. And X will support up to 6 order of polynomial because it's almost rarely case when we need to use such large level of correlational analysis. Because it's too hard probability that you will fall in overfitting when you try to use given order of polynomial. So general principles, we can use trend line in spreadsheet by adding it to a few type of trend lines like line chart, bar chart, and definitely scatter plot. So first of all, it's the main question to choose correct chart type which is depend to your data you operate, and then you have to add necessary trend line by visualization and by analysis of what you have. Maybe you can identify some kind of visual trend from your data. So benefits of usage Excel trend line, we can add the equation and the coefficient of determination for your spreadsheet. Most cases, if we use if our independent and dependent variables has a discrete data type or continuous, so definitely scatter plot has to be used, and if our independent variables has nominal ordinal data type, for sure line chart will be better. And so here is the way how we can add the trend line for our data set, and what kind of what type of trend lines has to be added, and what is again extra benefits immediately. It's possible to make forward backward prediction, and actually it's main goal of even most time why do we need this kind of analysis to make forecasting forward or backward. and learn about possible development of like our objective of studying. So it's made regression analysis very useful, for example, in epidemiological studies. But also it's very useful for various kinds of business analysis as well. Okay, and here is example how we can see multiplied trend lines added to the single data set, and what kind of expected what kind of trends we have expect, and there, so models given and expected quality of fitness or coefficient determination in this case represent quality of model, and so closely it will be for one, obviously its better model will be. So our data obtained via particular simulation will best fit our real experimental data. Let me also show brief practice on this. So here is we have like sales. In this case, I use simple visual question, a simple task, business task. We have some sales, for example, medicine or so, and we want to make prediction for future 2 months. So easiest way for sure it will be to visualize it with in this case also we can use scatter diagram, for example, and in this case I can add the necessary trend line models. So for example, let me show line, and I can add immediately the 2 months forecasting forward and visualize my model. Similar way, I can add for example, polynomial trend line second order with forecasting for 2 months, creation square value, and let me add the one more, for example, polynomial third order. So, and here is this point I want to give you some, present you some possible problem. So we have 3 models, and if we will carefully study a square value, we will see that largest result represented by third model, by polynomial third order. So we have to assume that it's like best model. But here is we have very high risk of overfitting, because as you can see, next 2 months we have expected sales will drop significantly. And we, in contrast, when we compare second order polynomial linear model, so they are relatively closely together. And if we consider last few months of sales, so we see that it's like more or less linearized. So we have to be very careful with choice of polynomial third order as best model, despite the technical indicator coefficient of determination say as this. That's probably could be something similar, something between linear model or between polynomial second order or linear model. So which is represented by this pair of trend line. Okay, and if possible, one more techniques to spend time. We can make prediction. Not this time. Maybe I should have time. Sorry. Okay, move into next type of model. Next type of analysis, transportation, transshipment, assignment model, and so on. So this time we will move out of statistical analysis into optimal management task solving as kind of mathematical solution. Or it's also part of linear programming known as network flow models. And it possesses special mathematical features enable development of very efficient Unix solution methods. So as of about possible application, so plenty of solution available. It's what is interesting for us. It's in various communication system and transportation system, then which is data analysis solution, and so on. So real huge number of applications available for this mathematical methodologies, but we every time has to be aware how to establish relationship between optimal mathematical solution with our real world problem. So that's every time keep in mind this problem. So clear by itself, transportation problem deals with distribution of goods from several points of supply to a number of points of demand. And the arrangements cost-effective partner needs to ship items from regions that they have limited supply, destination, and have demand of this good. So in fact, that's not only task for delivery company. Yes, they face it every day. But also if we also spoken about any resources optimization, optimal usage of any resources, so it will fit this mathematical condition, it will fit this mathematical model, and we can use it for for analysis. So in other kinds is resource allocation and scheduling. So all these things, not only just transportation goods, but also optimal usage of resource for mass production, or creating scheduling of human duties, and even up to educational schedules. Yes, really, our schedules, it could be covered under this mathematical model, and it's covered in this assignments problem. That's determine most efficient assignments, peoples to projects, sales of territories, contracts, and then so on. So, and again, we can extend this list with educational schedule. In fact, that it's this task, and even I know few software solution which allow to implement automatic creating of educational schedule on by using solving of optimal management transportation problem. Okay, so let's define transportation problem in mathematical way. We have now like m sources of our goods, and each item has supply capacity of S of I. Then it has to be delivered to a destination, and each destination, specific G destination, has D of G requirements for these goods. Objective: minimize total shipping cost and supply the destination with required demand from available supply cost. So what is known is transportation cost from any kind of source to any kind of destination. So and what is key points when available methods which allow to give for us optimal solution working fine with balanced transportation problem. So means total supply has to be equal to total demand. In this case, we are talking about balanced transportation problem, and our solution definitely could be found, and it will be really optimal. And here is we have like example of task when we want to deliver from some given capacities to given destination points with different requirements. And assumption. So it's given slide. We have some important assumption about implementation of transportation routers. So like linear programming model has constraints for supply at each source and demand in each destination. Our constraints are equalities in balanced transportation problem where supply equal demands, and constraints contain inequalities in Balankin model where supply does not equal demand. So in our case, also as I said, we know cost for delivering, and here it's possible to create our major objective or minimize total shipping cost when we will multiply cost of transportation from particular source to particular destination, but number of units that has to be shipped from that source to that destination. So here we have a creation like this one. After that, we have add necessary constraints, like we can't take out from specific warehouses rather than the available resource, and we must not deliver more than demand point required. So all these things is constraints for our task. So then flow in, flow out have to be identified, how many items we get. Expect to use spreadsheets. So here is given one of possible recommended layout, one of few possible recommended layout when that's actually already solved. Flow in, flow out, and at the middle, at orange area, we have already solved task with one of possible solution. So major objective is some product function, which is objective value, and it's actually multiplication of two matrices, cost by delivery plan. So when we find such combination of delivery plan which minimize results of some product function, it's definitely will be optimal transportation plan. So here is also how possible to make configuration for Excel solve. So here is this point major benefits of usage spreadsheet. You no need to perform to manually solve system of linear equation. You only need to make necessary configuration for Excel solver data tool, and it will provide for you one of possible optimal solution if available. So it's just need to provide like target cell with objective function, range which could be updated, list of constraints, and our objective. So what we want to minimize, maximize, get into specific value, and so on. But in reality, actually never have. So every time we have inequality in resource and request. For example, if total supply exceeds total demand, so we have to establish our mathematical balance. It's actually key point for understanding. When we spoken about mathematical solution for transportation problem, we have to follow requirements of linear programming methodology. As a result, we want to establish dummy objects which could be used only within mathematical solution. In this particular case, we have resources greater than demand. Okay, we add dummy demand, which will utilize this resources with transportation cost of 0 because given goods will not be transported. In contrast, complex situation, And there is no really, there is a few recipes which could give for us possible solution, but they all are questionable in case of are they really optimal. Anyway, simplest solution will be exactly the same. It's add dummy warehouse which stored imaginary resources, and consider that we again turn our unbalanced problem into balanced. So this case, again, transportation cost will be 0, and just we will have unmet demands, so not all real customers will resell their goods, so it could happen. And here is given another useful layout which could be also very helpful in case if you want to Excel spreadsheet tool. So let me maybe there demonstrate this layout in live mode. So here is we have. So here is in this area I have my future future transportation plan. Here is I have my known transportation cost, also known resources and demand from our warehouses. And so first thing that has to be done, it's like we have to add the necessary we have to evaluate our resource and request. In this case, it has, as it's obvious that we have resources resources smaller than demand, so we have unbalanced problem. And to get in line and go to optimal solution, we have to add dummy warehouse, which will be which will have all necessary, which will provide necessary imaginary resources. Then it has to be added into all this flow in, flow out formulas. Maybe I will use existing. Yes, so here it is. So here is example how it's have to be added. So here is that's imaginary resource with zero transportation cost. So here is we have adjusted objective function which must also involve usage of our imaginary resource, and after that we can start our solver analysis and feed it with data. So in this case, I will just not proceed. I will give this demonstration like for unbalanced problem. We just feed it with data, which give for us our objective function, our objective optimization minimum. So range we have to change, and our constraints, which spoken about, that flow out must be equal availability, flow in must be equal demand, and results must be integer because we decide that only integer units must be delivered. And our model simplex linear programming. So when you just press solve, you will get like value which have to identify your transportation plan. In my case, I will cancel it because I have not yet added in this design my dummy object, so I can't proceed as is despite I configured it. So again, what I want to say in here, that you have to be carefully understand and you keep every time in mind algorithm of solving problem, because Excel can do calculation even if configuration not yet finished. So here is, please keep this in mind. That's very easy fall into errors. Okay, actually that's example, correct example for this case which I have just demonstrated. So as you can see, here is added D dummy row as well with 20 availability as given capacity. And here is we have updated transportation cost matrix. Definitely we have to update it flow in, flow out function. And here is one of possible optimal solution about how make this delivery. What is key point? It's because the resources are imaginary, so they are not exist in reality. These assignments, which 20 items has to be delivered into third shop, can't be executed in reality because this resource does not exist at all. So that's all things I'm going to present as basics of introduction for data analysis with help of spreadsheet, and which considered statistical data processing and a few biostatistics method, and with up to some intro into optimal management task solving by using linear programming methods. Okay, now we will move into second part of our lecture.